Very good day to all. I welcome you for the lecture series on material science and metallurgy. So this is a continuation of the first lecture series. In the first lecture series, we have discussed about material characterization. Um, we have defined what are the different types of materials and how we characterize those materials and what are the different properties of materials, elastic deformation, plastic deformation, like that we have discussed. So this particular lecture series, we'll be discussing about the testing of materials. So why do we need testing of materials? Before getting into this topic, uh, I would like to explain the flow of a manufacturing process. So once you design a component, that's the first stage in any manufacturing process. That's the design. Once you fix your ideation and then you finalize your design, then comes the manufacturing part. So manufacturing involves, the first step in manufacturing is material selection. What type of material we are using for this particular application. So with a live example, imagine you have designed an engine, a small engine for a two-wheeler. So you have finalized your design for the engine. Now comes the material selection part. So what material can you use for the engine? You have finalized you are using a metal. Since engines are made of metal, the reason being they have to be thermally conductive. Non-metals don't have that much conductivity as compared to metals, and they should have good strength to weight ratio also. So based on these qualities, we have come to an assumption that we are selecting a metal for our engine. So now comes the question, which metal am I selecting? So the basic criteria for an engine is that it should be able to withstand the load, torque produced by the crankshaft, by the piston, connecting rod, and also it should be able to withstand the explosion which is happening inside the piston cylinder chamber. These are our requirements. So you can use any metal. The widely used metals are steel and aluminum. Widely used metals for any application you take, steel and aluminum comes first. You can either use steel or you can either use aluminum. So based on our requirement, thermal conductivity and strength, you have to select between these two materials, steel and aluminum. Why I am fixing these two is because they are cost effective and widely available for mass production also. So you can either choose steel or you can choose aluminum. So main criteria here is thermal conductivity, and also it should have load bearing capacity also. So if you use steel, the main drawback there would be the thermal conductivity and also the corrosion problem. So we are switching to aluminum. So engines are predominantly made of aluminum and its alloys. The reason being, aluminum is a very good thermal conductivity. Aluminum has very good thermal conductivity and also it has a good strength to weight ratio. And it is corrosion resistant. So these are the reasons why we are going for aluminum as a material for engine. So this is how the material characterization works. And once you fix a component based on these properties, the next step would be to test the material for its load bearing capacity. As I said, thermal conductivity can be easily identified. But what about its load bearing capacity? Suppose you are developing a new alloy of aluminum. We don't know any specific qualities of this material. So what you have to do is you have to test each and every property. What's its tensile strength? What is its compressive strength? What about its bending strength? So on. What about its shear strength? So everything has to be calculated. Hardness. So these steps, these properties can be evaluated with the help of material testing. So that's what we'll be learning in this particular lecture series. In the upcoming two lectures, we'll be discussing about various material testing methods and how they are used to test the quality of material. So there are two major categories in material testing. One is destructive testing or conventional testing methodology, and another one is non-destructive testing. So destructive testing involves breaking the material, destroying the material. So if you have to find its strength, hardness, these properties, you have to destroy the material to notify these properties. Another type of testing is non-destructive testing, where without harming the material, we will be doing these tests. So why the concept non-destructive testing came? Where we should use this non-destructive testing? And how does it differ from the conventional testing process? We will discuss these things in the next lecture. Thank you, students. We will see in the next lecture.